We're going to work on the lead code problem, diameter of a binary tree. So in this problem, you'll be given the root node of this tree and you're supposed to find the diameter. So when we say diameter, what they're saying is that it is the longest path between any two nodes of a tree, and this path may not necessarily pass through the root. So it could be like any of the subchilds of the tree could have the longest path. So actually this is I think important edge case which some people miss, and the interviewer has to remind them. So usually the way to solve the problem is to find the height of each node of a binary tree, and we just keep calculating, okay, what's the height of the left node, right node, and add it. Because imagine here the left node height is 2, the right node is 1. So that way we can see the path between those two nodes is 3, and we return that as the diameter of the binary tree. So what we'll do is something similar, is like we'll calculate the height of every node in the binary tree, and we'll also have a calculation of what's the max path. And yeah, we'll keep doing it until we have traversed all of the nodes of a tree and we have the max path available. So yeah, I'll try solving it. So first thing we need to do is a helper method. So this method is used to find, given a node is helps us find the height of that particular node. So what we can say is that tree node. So the way we'll do is using recursion. So recursion always has a base case and a recursive case. In this case, the base case is the node is null. So if node returns 0 because there's nothing, no height. Else, we now need to find the height of the left and right nodes of the tree. So we say int left equal to, so this finds the height of the left node, and similarly you'll find the height of the right node. And then we say return 1 plus the max of the left and right heights. So this helps us find the height of a node, but what we need to do is find the max path. Now there are many ways to do it. The easiest way I found is to create a variable outside of the main method. So we just say create int max equal to -1, and here we always calculate what's the value of max. So we say max equal to left plus right. So yeah, essentially what we're doing is we're keeping track at each node what's the max height which can be achieved. So yeah, afterwards we just call this method. We say height root, and then we say return max. So yeah, just recapping, we're going to find the height of all the nodes of the tree, and we're also going to keep this variable max outside of the main method, which helps us to calculate what's the max path at each point. And at the end, we'll just return the max path. So this method, I'm creating this variable outside of the main method. Some people, what they do is they create an object and they pass that object inside. Because if you pass an int variable inside, it gets overwritten and only local copy is available inside the method. So that's why some people create an object which has a property max and they pass it inside the recursive method. So that's possible, you can use that solution, but this is the easiest solution I found. So yeah, let's try running it. Okay, both the use cases are passed, and we'll try submitting it. Okay, so yeah, the time complexity is O of n, where n is the number of nodes of this binary tree, and the space complexity is also O of n because we are using recursion. So what happens is whenever you use recursion, all the variables are stored in a stack, and essentially is waiting the result from the previous recursion to come back. So that's why the space complexity will be O of n, with n is the number of nodes of the binary tree. So yeah, let me know if this solution looks good, and if anyone has an easier solution besides this or using an object, just add it in the comments. Thank you.